What I showed you last time was how we use the mole as a conversion as well as an important tool for us to understand ratios in chemistry, but we can also do a little bit more with the mole. So previously I showed you how we can take a number of moles and convert it into a mass. And then we did the reverse where we took the amount of grams and the mass and converted it back into moles. What I wanted to show you this time is that we can actually use the molar ratio or the molar mass or what we would call Avogadro's number to help us figure out the number of atoms or molecules that exist in a sample. So we're going to take a look at some examples and we're going to work our way through these to see how we would actually do this. So first thing you're going to want for this is a calculator. You're definitely going to want to use a calculator for this because we're going to be working with some numbers that are a little bit difficult to do on your own, to say the least. So make sure you grab a calculator. I highly recommend a scientific calculator. And if you're using a scientific calculator, something you're really going to want to make sure of is that you have an exponent button. And I also really like a calculator that shows me my work on one line and shows me my answer on the other. A calculator like this runs you about like 15 to 20 bucks. And you can probably get away with one maybe on your computer or online or even on your phone. If you turn your phone sideways, it'll give you a scientific calculator. But those are kind of the features that I usually look for when I'm picking one up. Here's the question we're going to work through. How many atoms are in a 3.00 are in a sample of magnesium where there is 3.00 moles? So previously, one of the things I said is always start with what you know, and we know we have 3.00 moles of magnesium. Now, before, what I would have had you do at this point is use your molar mass. But we need a different ratio because we're dealing with a different calculation. We're going from moles into atoms. And so we need to figure out a different method that we can use here. Luckily, there is a ratio that we already know, we just really haven't explicitly talked about it. And that is the fact that 1 mole of any substance is the same thing as 6.02 times 10 to the 23. I'm literally just going to write things here because it can be anything, even magnesium atoms. So before, what we did is we turned our molar mass into like grams over moles. Well, we're going to do the same thing here. 6.02 times 10 to the 23 is the same as 1 mole. And so this now becomes a ratio that we can use to help us answer questions like this. So what we're going to do is we're going to take our 3.00 moles of magnesium. We're going to multiply, dividing line, unit we want to get rid of goes on the bottom, goes on the opposite side of that line. So this one's on the top. We're going to put moles on the bottom. What we want to convert it into goes on the opposite side. So atoms. So going to be atoms of magnesium from moles of magnesium. And then make sure you have your numbers matched up with the right units. In 1 mole, there is 6.02 times 10 to the 23 atoms. So here's where you definitely need your calculator. So what we're going to do is we're going to take our 3.00, multiply by, and just for my own sake, I like to put this in brackets when I use my calculator. So bracket 6.02. Now, rather than go times 10 to the power of, don't do that. Instead, you should have a button on your calculator that does this for you. Chances are this button says EXP. It may say E, it might say EE, or it might actually just say times 10 to the X. And so whatever button you're using, you want to like find that function, the scientific notation function on your calculator, and press that. See, mine says E, And what that is times 10. So now all I have to do is punch in what the exponent is. So rather than write 6.02 times 10 to the power of 23, I wrote 6.02e23, and it means the exact same thing. And there's my answer. So my answer comes out to be 1.81 times 10 to the power of 24. Let's cover that up so that we can see. Now, again, we want to think about units here, and our units, we canceled out moles of magnesium. We're left with atoms of magnesium. So I'm just going to write that below, atoms of magnesium. And there is my final answer. Be a good person. Box that for your instructor so they know what you're doing. And there it is. Okay, so that's how we use Avogadro's number, 6.02 times 10 to the 23, to do calculations for the amount of moles, or the amount of atoms from moles. So let's try a few more examples here. So in that last example, what you got to see was how we were given the number of moles and converted into a number of atoms. Let's try something a little bit different where we're going to go the opposite way. So in this example, we're going to take a look. It says how many moles are in a vial of argon gas containing 4.31 times 10 to the 24 atoms. So like always, start with what you know. So we have 4.31 times 10 to the 24 atoms of argon. And we want to convert this. And so we're going to do our conversion. And we want to get rid of atoms this time. So that means atoms goes on the opposite side of this line to cancel out. And so we want atoms of argon down there. We want moles of argon on the top. And now think back to the number and the ratio we were dealing with. The ratio we were dealing with was 6.02 times 10 to the 23 things, or atoms in this case, is equal to 1 mole. Now, you have to make sure when you do this that you match up the numbers with their units. You can't switch that. So moles is on the top in my equation. So that means 1 goes on the top in my equation. And 6.02 times 10 to the 23 is going to go on the bottom. That way atoms can cancel out, and I'll be able to calculate my answer. I'm going to write it down here so it'll be a little bit easier to see. So then pull out your calculator again. Again, I like to use brackets, so I'm going to go bracket 4.31 times 10 to the 24. Close my bracket to get that one thing. Now, you could go multiplied by 1 divided by, but it's going to mean the same thing. So you could do that, but you can also skip that 1 if you wanted to. And then 6.02 times 10 to the 23. And there's our answer. It is 7.16 moles of argon. So there you go. That's another way that we can set up one of those ratios. So now that we've seen how to do that, let's take a look at how we can add another little piece to this, because remember that Avogadro's number isn't just for atoms, it's for moles of whatever we're dealing with. And so let's take a look at an example where we're not given atoms, but we're given something a little bit different. So in this example, you'll see it says how many atoms are in 4.60 moles of H2O. And so it looks pretty similar to the last one. We're trying to solve atoms. We're given moles, but I want you to notice H2O. H2O is not an atom. H2O is a molecule. So we're going to have to deal with that in some way, but before we do that, let's start with what we know. I have 4.60 moles of H2O. I want to get to atoms, so I need to convert first of all, I should probably find out how many H2Os there are. Because if I know how many H2Os there are, what I can actually do is then think about how many atoms are in H2O. In every one, I'm going to say MC molecule of H2O, there's 3 atoms, right? There's 1, 2 H's and 1 O for a total of 3 atoms. So I can actually use this as a ratio. 1 molecule of H2O is 3 atoms. So what I need to do is figure out how many molecules of H2O there are. And luckily we can do that because in 1 mole of H2O, there is 6.02 times 10 to the 23 atoms, or sorry, molecules. My bad. So I was going to write atoms up here just because I had been, but this is not just for atoms. Moles is for anything. Remember I talked about how it's like a dozen. You can have a dozen of anything, which means 12 of whatever you've got. And in this case, I've got a mole of H2O. So I've got 6.02 times 10 to the 23 of them. A mole can be for any substance, anything, any object, but we're using it for chemistry. So we're usually talking about atoms, molecules, those kinds of things. So since I'm dealing with H2O and moles of H2O, I don't find the atoms right away. I find the molecules of H2O. But then that's going to get rid of moles of H2O for me. And rather than like calculate my answer and then do another line, I can actually just continue my work with another conversion line. And this time what I want to do is I've gotten rid of moles of H2O with this previous calculation. What I want to do next is change the number of molecules into the number of atoms. And remember, in a molecule of H2O, 1 molecule of H2O, there are 3 atoms. And so by punching this in your calculator, you're going to be able to calculate how many atoms of H2O you have, or how many atoms are in this much H2O. So again, just punch it in. So 4.60 multiplied by 6.02 times 10 to the 23 multiplied by 3, I get 8.31 times 10 to the 24. So by setting up this conversion, I was able to go from moles to molecules to atoms to find my answer. So hopefully what you're seeing now is that we can start to do a little bit more than just one conversion, and we can actually start putting it all together. So what we're going to do is another example, and this example is going to incorporate everything that we've done so far. So we need to first of all read it carefully, think about what we can convert and how we can do that. So let's take a look. So here's what we're doing this time. How many atoms are in 6.25 grams of F2? So we're starting with grams, which is what we did in our last video. We're trying to find atoms, and I want you to note, this is not an atom, this is a molecule. How do I know that? Because it's got more than one atom connected together, which automatically tells me it's a molecule. So what are we going to do? Well, as always, start with what you know. 6.25 grams of F2. And I'm going to want to convert this. What am I going to want to convert this into? Well, we only really have one conversion that involves grams. That means I need to go from grams into moles. How am I going to do that? Well, we need to use the molar mass of F2. So F2 is 2 fluorine atoms And fluorine has a molar mass of 19.00 grams per mole, which means 38.00 grams per mole if we're dealing with F2. So that's going to be my molar mass, which is my first ratio that I need to use. 3.00 grams per 1 mole of F2. So what does that do? Well, grams of F2 divided by grams of F2 goes away. And now I have moles of F2. So if I have moles of F2, what can I convert this into next? Well, because it's a molecule, I can't go straight into atoms. But what I could do is go from moles into molecules, because 1 mole will be 6.02 times 10 to the 23 molecules. So I can now set up that other ratio and use it right here. So I want to get rid of moles, so moles is going to go on the bottom. I want to turn it into molecules of F2, so that's going to go on the top. 1 mole of F2 has 6.02 times 10 to the 23 molecules. But I'm at molecules, I'm not at atoms, and that question wants me to find atoms. My previous calculation, moles divided by moles, that goes away. So now I have molecules, and I want to turn it into atoms. So atoms is going to go on the top, and molecules is going to go on the bottom. So atoms of F, molecules of F2. In every 1 molecule of F2, there's 2 atoms, right? F2. And that's going to get rid of molecules and going to leave me with an answer in atoms. So after you punch this through your calculator, what you're going to find is that it's 1.98 times 10 to the 23. Sorry, I'm kind of running into my light here. I'll write it down here. So atoms of F. And so there we go. So by doing that, you're able to see what we actually get out of a multi-step calculation. So we can go further than just grams to moles. We can do grams, moles to molecules, or grams, moles to atoms, depending on what we have. We could go the other way if we wanted to. We could start with atoms and convert it to moles to grams and find that. But the real key here is that we can do lots of conversions because of all these different ratios. And I know it may look complicated, but mathematically, it's no different than changing like feet into inches or inches into centimeters. And just knowing what the conversion rates are is kind of the big step here. So remember, molar masses can be used for the grams to moles conversion and can be done or found using your periodic table. Avogadro's number helps you do that conversion from either moles to molecules or moles to atoms, depending on which you have. Remember, a molecule has more than one atom bonded together. And then if you need to go from molecules to atoms, you really just need to look at the number of atoms inside of the molecule. As with all things, practice it. Try it, check and see how you're doing, and ask if you need help. Hopefully this gave you a good start and is going to help you get on the path to knowing how to use moles effectively. Because up next, we're going to add another little bit to this and do what's called stoichiometry. So thanks for watching. Good luck, and I'll see you next time.